Okay, guys, our second video in Force in Motion is going to be over Newton's laws. So Newton has three laws. The first law, remember, the first law is the law of inertia. And the law of inertia says that an object in motion will remain in motion, and an object at rest will remain at rest unless acted upon by an unbalanced, or sometimes called outside, force. One of the examples that you should remember from class is our inertia egg experiment. Here is Bella trying it at home. Other examples include any orbiting satellite, because even though the satellite is in motion, it is in constant motion, so there are no unbalanced forces acting on it. And another example would be like a clock hanging on a wall. Okay, it's not in motion, it's at rest. Newton's second law is the equation of F equals ma. Okay, and remember that the F is going to be force, which we're going to measure in newtons. The M is mass, which we're going to measure in grams. And the A is acceleration, which is going to be measured in meters per second squared. Now, when we look at examples of Newton's second law, often they are given to us as a comparison between two things. So they'll usually change the force, or they'll change the mass, or they'll change the acceleration and ask you about one of the variables.
You okay? Mom! Okay.
In class, we talked about some specific examples of a really small mass with a really high acceleration can provide a large force like a bullet, or a really large mass with a really small acceleration could also provide a large force like a slow-moving train. Newton's third law deals with action-reaction pairs, which states that every action has an equal and opposite reaction. Some examples that we have discussed before include rocket launch, as well as skateboarding, where you push your foot backwards in order to have the skateboard go forward, and rowing a boat, because you're going to pull back on the row in order for the boat to go forward. So it's equal and opposite.